Well, I guess not really. Huh? They leave the best for the last, so I guess the last for the best is one of them. So very happy to be here. My topic is really big. I mean, 5G by itself is a world, and integrating. You can imagine integrating AI in 5G. My concentration today is going to be basically on the RAN side, which is radio access network. I will not be going towards the whole end-to-end side of it as a turnkey, but trying to make it as short as possible because I know everybody's tired and want to take off. So I hope this works this way. The inevitable integration of AI in 5G is happening. I mean, whether we are out there seeing it, feeling it is another story, but on the background, it's happening, and it's the perfect path to move towards 6G. 6G is going to be extremely expensive, extremely data processing intensive, and very few operators are very reluctant to a degree to be able to do that. But it's the future, and it's going to happen. Inferencing at the edge. A lot of our professors talked about this. This is the processing at the edge. Companies such as Turkcell or Turk Telecom, they're not willing to process their data as an end-to-end because it's extremely process intensive. Data is expensive, and they're willing to basically talk about new technologies such as the edge on the UE, which is the user interface. Integration of AI on 5G. On the research domain, it is extremely competitive. There's a lot of companies that are talking about this, but resources and financial factors are a big questionable factor. Applying AI to solve complex wireless challenges. Wireless by itself is electromagnetic frequencies, signals, very hard to harness, very hard to understand. Everything around us has an electromagnetic field that is rotating around everything. Every object here can absorb and reflect signals. So in order to lock into a particular signal, it is very hard, and it's very, very computationally intensive. AI-based on-device radio. On-device is a Google term. I used it with their permission. They are majorly advertising on this factor, which is basically AI on the edge. So we're going to talk about that a little bit, touch base on it. AI improving 5G quality of experience. Carriers and operators have to be very, very conscious of the quality of experience. If the experience of an end user is bad, they're going to drop their services and not going to like it, and revenue is going to be touched. So experience comes as at a price, and the price is that your network has to be extremely robust. So AI will be incredibly advantageous, cost-effective, and very, very efficient. AI improving wireless communication, we all know that. With on-device, again, I'm going to talk about that. AI and ML, the key to the path to 6G. This is a video. It's a 3-minute video. I don't know if I should play it, but this was a video done by the NVIDIA CEO. He's my hero, so I think we should listen to this. It's fantastic.
I am an explorer, traveling across the Atlantic to unlock its mysteries, and back in time to understand the origins of the universe. I am a visionary, bringing sharper focus to researchers. And brilliant clarity to surgeons. I am a healer, making treatments as unique as every patient, and giving new life the chance to thrive. I a guardian, looking out for dangers around us. And in the depths below, I am a helper, enabling healthier, more sustainable crops. Bringing them to market faster and preparing them for the table. I am a creator, building virtual worlds to help robots learn faster and make our connections stronger. I am even an avatar, and you can ask me any question.
Who made this song?
Ava used artificial intelligence to write this song, and it was recorded by the London Symphony Orchestra. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
You can imagine NVIDIA. What does NVIDIA do? They built GPUs. Without GPUs, we cannot have AI. So everything that happens, all the data goes through their processors, goes through their devices. The more robust their devices, the more application we can cover. What we saw in that video has to happen on an infrastructure of telecommunication and wireless communication. Without that, in other words, both of them as a synergy combined and integrated together is going to be unbelievable. So every benefit that we get from healthcare to manufacturing to education, online or physical, has to be done through an infrastructure on a wireless network. The essential role of AI in 5G is inevitable. 5G and AI are two synergetic essentials, as we talked about. Applying AI to solve difficult wireless challenges, very great, but there are a lot of sharp, very intelligent individuals and companies putting in billions of dollars to be able to do that. So, and AI playing an incredible role in integrating. It's like a connection between 5G and 6G. Right now, carriers are not going to spend billions and billions of dollars to move to 6G. Why should they? Because the money that we pay does not encompass the cost that they incur on their network. So AI helps 5G to migrate much easier, much more fluidly to 6G. Some of the very important things, I don't know if people in here are telecommunication background, I don't know, but basically I'm going to touch base on the network optimization, which is extremely important. AI enhances that without the involvement of humans. Like, there's nothing wrong with that in getting involved. We've done it ourselves, but AI will do it much better. So data gets analyzed much more accurately, much more robustly, and much more expeditiously. Designing and managing clusters, which is very important. I don't know, well, clusters are where base stations are. Base stations are where those radios are, where we get our communications through our UEs, which is our cell phones. Those base stations cost hundreds of millions of dollars each. And you can imagine in one cluster, you can have close to 50 base stations. So multiply 50 by $100 million. How much is that? That's a lot. In Istanbul, you might have close to 150 clusters. Now, in order to manage that, can humans do it as well as they think they can? Of course they can, but AI can do it much better. You do not have to have a hands-on approach on designing, evaluating, and optimizing a cluster that can give us a much better service. What would be those services? Medical-based services, health-based services. A lot of our hocalarımız talked about it. Sensors, how do they work? I mean, sensors just work on an edge, but what happens to the data that you capture? It has to be transferred all the way to a data center, either a cloud, and get analyzed, computed, and then sent back. We want to curtail the amount of data that we're going to send to the cloud. I'm not an anti-cloud guy. I worked on it actually in my youth, and we were just really gung-ho about it. But it is too expensive, too computationally process-wise, too complicated. We want to shorten that. And AI on the edge will be able to do that. I guess I can go through this. Factories, cost, CapEx, OpEx, these are very meaningful terms. CapEx is capital expenditure. In engineering, you may consider, oh, why do I have to consider, cost, capital expenditure? What is that? What is OpEx, operational expenditure? You do have to, because your boss is going to come to, they've done it to me. They're going to say, okay, you've done a great design on this processor. You've done a great design on this, let's say, cell design, but how much is it? How much is it going to cost us? Well, this is the cost of it. No, it's not going to happen. So they're not going to accept it. We need to recognize that, again, with the integration of AI, we'll be able to control the CapEx and control the OpEx. You engineers have to consider that. It is not just designing the right circuit, designing the right ASIC, designing the right FPGA. That's not enough. It is why you're designing it, how you're designing it, and what applicable solution are you trying to get out of it. That's very important. Extended R. Some of our professors talked about it too. It's V2Rs. V2Xs are what? Vehicle to everything. Those are factors involved in getting our day-to-day interaction on the streets right now. So AI, again, an application that can really, really enhance that. Factories are being, right now as we speak, reconfigured in getting AI integrated into their system and transferring data on a 5G network to get it analyzed. So it's something that is happening as we speak. The synergy between the two, advancement in AI is making 5G work, and then vice versa. So together it will work. If you take one away from the other, it will actually be bad for us. So if you integrate them, as far as the level of performance is concerned, KPIs. KPIs are a major factor in defining enterprise-based customers that will say, okay, what KPIs in our SLA, which is service level agreements, are we going to define in order for you to have our account to give us service? Those are factors involved in getting 5G as our core infrastructure and AI in making it happen. Lots of discussions are made on how the edge AI is going to work. Edge AI is very complicated. Google is working on it right now, but they need to create processors on the PHY layer. PHY is a physical layer, which actually what everything happens, there's a logical signaling and there's a physical signaling in the UE, which is our cell phones, that have to be able to recognize the processor that will manage the edge-based computation. Why do we do that? It's for efficiency, real-time decision-making, and reducing the need for constant communication. We do not want to have constantly triggering queries. What is triggering queries? Asking the system to give us services. Give us services, but I don't want to send signal out there in the cloud and getting a response back as to getting my solution into it. So Edge will be able to curtail that, get the processing into it. In factories right now, inventory problems are happening on a daily basis, especially after COVID. COVID was horrible for supply chain. I'm sure you all are aware of that. If we had AI at that time implemented into the factories that could understand what was going on with the production, and directly, without human intervention, communicate with the stores or supply chain environment and get an update on data, we would not have what we have. Inflation actually is affected by that too. So it's very, very important for us to recognize this factor. You guys have to see this too, so it's wonderful. Please.
Telcos are turning to generative AI to transform their business, from customer experiences and employee productivity to network and RAN operations. They're using domain-trained large language models to bring new levels of understanding to customer care, efficiently addressing billing inquiries, personalizing mobile plans, and tailoring promotions. With generative AI, they're deciphering complex network logs, translating them to English, and generating incident summaries to automate customer communications and speed resolution. Generative AI enables telcos to have dynamic conversations with their network data in plain English. This lets them quickly identify areas experiencing network performance issues and specific buildings with the largest affected populations to prioritize deployment of field technicians. Generative AI allows for human-like interaction with the network in near real time, powering faster resolution with proactive responses to storms or other network disturbances. Generative AI is also being used to proactively monitor network performance, predict possible degradations and impacts, and provide new insights for repair planning. Large language models are assisting network technicians in the field, diagnosing issues and recommending resolutions by synthesizing large volumes of technical manuals.
Hi Rob, I'm Violet, your virtual assistant. How may I help you today?
Hi Violet, I'm working on case ID 3367. The user has reported intermittent connectivity problems. I ran packet analysis using Wireshark and there are a lot of ICMP destination unreachable messages from the same IP address. What could be the issue?
This likely indicates a misconfigured or malfunctioning network device or application. Check the network device configurations and logs for any errors or issues, and verify that the IP address in question is not being blocked by a firewall or security policy.
And in network planning, generative AI can recommend optimal design and configuration of networks and cell towers. As the industry engages in 5G and 6G architectures and deployments, generative AI can simplify and streamline access to complex documentation, enhancing collaboration and understanding of industry standards. NVIDIA and our ecosystem of partners are supporting the industry's move to generative AI with a growing number of solutions, unlocking new levels of insight and efficiency, and paving the path to AI-powered telecommunications.
On a single cluster. So you can imagine the whole network, how it has to work and how data had to be captured and analyzed constantly. I just wanted to show that that video so it would tell you how the 5G network works to a degree, what these base stations are, and how AI can be integrated into that system. These are the on the research domain on full duplex. Now, when I say full duplex, we're pretty much talking about, if you talk about the RF side of it, it's called frequency division duplexing and time division duplexing, which means signals have to be either on an uplink and downlink frequencies and has to be transferred based on this structure. AI will take care of that in a much more robust way. These are not very simple tasks that we can just talk about. On the field, there are drive test individuals that drive for hours and hours for one single FDD-based signal that they can capture on a spectrum analyzer and map it and understand what was going on at what frequency and then what channels. Power saving, extremely important, especially in countries and environment where power is extremely expensive. AI will be able to handle that, basically diminish or curtail the amount of energy that will be used for the 5G environment. I'll just point out the important ones. MIMO, maximum input, maximum output, those are for antennas. Antennas are extremely important, but they take a lot of energy to operate. And there's an energy called beamforming that follows individuals in 5G. Every individual will be assigned a signal depending on how far they are from a base station. AI manages that distribution of that signal to the end user. Any one of us are the end user. So that is just very simply, you're saying it is very simple, but doing it is extremely difficult to program. And I've actually done that myself, and it's very, very hard. Environmental sensing, these are the important ones that I'm going to point out. Environmental sensing is if it's raining, if the weather is really bad, if there's a thunderstorm, there's things that are going on that affects electromagnetic signals. Water sucks up electromagnetic signals. So that's terrible for us because we're going to get weak signals and not going to be happy. So AI will be able to send or parse the antennas in a way that can direct a better signal to individuals, even in terrible terrain. Vehicular communication, very, very important. There's a billions of dollars investment done by companies like Tesla. We've all heard of them. The vehicle to X, vehicle to vehicle, vehicle to individuals. These are done by AI now. They're using it. They're not extremely effective yet, but they're reaching a point where the SLA, as we call the service level agreement, is going to be at least 6 nines, which is 99.99. So means it's almost on an instantaneous, real-time communication, which is, again, your network has to be so robust, so accurate as far as programming is concerned, and have enough computational process to be able to address this application. 4 minutes? 4 minutes? Ooh. Challenges, hard to model problems as far as AI is concerned. Hugging Face has models, pre-trained models right now. You can find them. I've seen it myself, I've looked at it, I've opened it, and I'm going to discuss it with some of our colleagues later on as to how we can apply it to some of our projects that we have with Turkcell. But it is very complicated, and it's not fully defined. We have to fine-tune it to be able to get it customized, and we are willing to do that. We're looking for students to be able to support that, especially graduate and PhD level students to be able to assist on this factor. And I'm looking for that, so we can talk about that later on as well. We talked about the computational infeasibility. Very hard processors are working constantly. We want to diminish that. We want to bring it on the edge. We've talked about that already. Non-linearity, there's quite a few. We have to be able to address the non-linearity of the processors and the system level and figure out how the output is going to be more accurate to what the end result that we intend to have and be able to solve that. Enhanced device experience, AI improving 5G end-to-end system. I think I've already touched base on that quite a bit, though I'm not going to go through this too much. Another issue that is very, very important as far as the environment is concerned is the battery or the energy. So they're very, very expensive and they're very toxic. And US is running ahead of everyone else as far as curtailing the amount of toxicity on the battery energy side. So we have to be extremely careful of that, and AI is very comfortably, to a degree, can help us in that factor as well, which is very important. Generative AI can enhance wireless sensing application. These are all applications that are very good, very important for RF engineers. And I'm not sure if you have a lot of RF engineers here or not, but spectrum sensing, very important. As far as the frequencies are concerned, frequency is very, very expensive. Turkcell bought, I think, 17 megahertz of bandwidth for $17 billion. 17 megahertz is not a very wide band, unless it's a time division duplex, which is uplink and downlink in the same spectrum, at the same frequency. But the amount of capital involved in getting this done is enormous, and we need to be very conscious of that. And AI is, we believe, as far as RF engineers are concerned, can be very, very effective in controlling that. Contextual awareness was the V2X, as I talked about earlier, and all that has to happen in real time. Can you imagine, again, the computation of data real time? It's almost close to, if you imagine, impossible. But AI, we're hoping generative AI actually, would be able to assist us. And there are actually models being built as we speak. NVIDIA is one of them that is promoting it. And I have kind of a close relationship with them, so that's one of the reasons that I've basically used their videos. And I talked about the RF sensing. This is what we were talking about, vehicle to X, or everything, pretty much. All that has to have an instantaneous communication with all of the elements. And again, very complex. GPSs get involved at a certain level if need be, but all that has to be almost at real time again. So you can imagine the complexity of the network and the amount of data we have to capture, where we have to collect them, how to evaluate them, computate them, and get a result, get an output. Very, very, very intense, data-intensive network. On-device, Google is big time on on-device. We talked about that. And their biggest challenge is basically battery. Again, battery, you might imagine it to be, oh, okay, just a simple battery factor. No, it's very complex. It has to be on a long term, and it has to work for a far, long time period. And so that needs to be addressed when they are talking about the on-device. On-device is the edge AI that we all talked about. Computation and building models basically at the UE and devices. UEs are your cell phones. This is repetitive basically. As I said, I wanted to concentrate on the RAN side. That is the base station that I talked about. We are putting computational factor on the base station now. The communication on the electromagnetic field will be directed to the device. This is the UE that we talked about. This logo is an integration of AI into the process of edge AI, basically, and it reduces the network loading, which is incredibly important factor in designing your 5G network that gives you better quality of service. More seamless mobility, which means you're allowed to roam around more without handing over to another network, which is another very important factor. Because when you're running a video, you're talking to your family on video calling, you do not want it to be disturbed. So for that seamless operation to happen, you need to be able to have a seamless mobility, and definitely Edge AI will be much more effective than your normal process that you're seeing it. You may not visibly see it, but we know as engineers that you're getting your signals cut off every once in a while, but it's not visible to the naked eye, basically. You have to be extremely accurate in seeing whether your video is being cut off to a degree, to a millisecond or short period, but it happens, and it has to happen. You cannot handle it without it, but on the edge devices will be able to do this in a far better way and much better quality of service that everyone expects. It comes at a price. It comes at a price of maybe cost initially, but in the long term, it will diminish it for sure. Okay, again, 5G is not even here. 5G is not in Turkey as far as I know. Is 5G here? Can anyone tell me if 5G is here? No. Some areas. Why is it in some areas, you think? I'll tell you why. Because they, let's say Turkcell, wants to implement certain locations for certain customers that pay a lot more than you do, a lot more than I do. So because the computation processing of those applications that the enterprise use is far more expensive than a regular site that you would have in normal places. If you look at your UE, you'll see LTE or LTE plus, but you will never see 5G next to it. But when I go to the US in California, pretty much 60% of California is a huge state. 60% of that state is covered by 5G. And the throughput is phenomenal, especially on the context, so it's the video factor. But your service can be parsed, meaning they will ask you, would you like it to be continuing? And if you say yes, they send you a text. If you accept and say yes, they'll charge you a lot more, and you have to pay for it. In Turkey, we don't have that option. I'm in close communication with Turkcell CTO group right now as we speak, and they're thinking about doing it, but I don't know if individuals such as ourselves, me included, are willing to pay for that. But there are still optionalities in that sense, and you'll be able to get that done. With AI, with the edge, the cost will be diminished. So it will be much more scattered, much more wider range that everybody can use. 6G cannot happen if 5G doesn't happen. So you can't imagine people having been got 5G and they're already talking about 6G. Theoretically, 6G is out there. We call them new radios, NRs. It's good, it's fantastic. Modulation is very, very high. The fast Fourier transfer on the inbound and outbound and inverse fast Fourier transfer is phenomenally large. And it's very robust on the rake side, rake receiver side. But very, very expensive. They haven't found the feasibility factor on the cost factor to be able to give that to us yet. However, governments are willing to pay for that. But if they are, they're considered as vertical markets, which will pay a ton of money for. So there may be out there right now 5Gs and possible 6Gs. I'm talking about the developed countries, even though we are developing here in Turkey, but we're talking about the 5 major ones, literally, US included. There are pockets of it that are being implemented, and we're kind of impervious of it, but it's being done. But the solution is phenomenal. You can pretty much do anything you want with it, and with unbelievable results and throughput. 6G is a world, 5G is a world. I mean, I can't even imagine talking more about it, but I've already gone past 5 minutes. Any questions?